The human microbiome, a term used to describe all the different microorganisms that colonize the human body. In fact, your gastrointestinal tract alone is colonized by thousands of different microorganisms, each forming unique interactions with each other and with you. Although we mostly talk about bacteria when it comes to the human microbiome, there are many other smaller groups of important microorganisms present. One of these groups are known as methanogens, named as such by their unique ability to produce methane gas. Over recent years, there's been growing evidence to suggest that despite their overall low abundance in the human microbiome, these methanogens may in fact play a large role in gastrointestinal health and disease. As such, my interests lie in better understanding this unique group of microorganisms and characterizing the potential roles that they could play in human health. I did this by utilizing publicly available DNA sequencing data from human fecal samples. If we're to think of these fecal sample sequencing data as a book, each one of these books contains all the genetic information taken from a sample of someone's microbiome, with each individual chapter representing a unique microorganism. With groups all around the world publishing thousands of these books each year, there are entire libraries available to those who know what they're looking for. Now, where my work comes in, I go through each one of these books from these libraries all around the world, and I pull out the chapters specifically focused on these methanogens. And I use this collection of information to explore the human methanogen community. Using this vast library of available data, I've been able to show genetic sequences relating to new species of methanogens or new chapters not previously recognized to colonize the human microbiome. In addition to this, I've also been able to show that the most dominant species of methanogen in the human gut is actually made up of two distinct groups with unique metabolic properties. In fact, one of these groups appears to be recovered at a higher rate from those with type 2 diabetes, whereas the other group is recovered at a higher rate in those with Crohn's disease. Collectively, this suggests that the differentiation between these two groups may in fact be essential to understanding how they interact in those with Crohn's disease, type 2 diabetes, and potentially many more different disorders and conditions. Although the microbiome is a complex system, this vast library of available data has allowed my analysis to shed light on one of the often forgotten smaller groups of microorganisms within the human microbiome, and I look forward to further characterizing these new methanogens I've recovered and potentially characterizing the roles that they play in gastrointestinal health and disease. Thank you very much.